All right, we're going to start our lesson 9.6 on logarithmic equations, and 9.6 and 9.6b use the same materials. And there's not very many examples, but I need to go through this with you so you see what you need to look for. First thing we need to look for is when you have the log base b of m, and that's written up here in this section. Let me get my highlighter going. Right here, this b has to be greater than 0 and also not equal to 1. And then another key ingredient that you need to remember, and it's important, is this m piece. M has to be greater than 0. And so that tells you we can use that to let us know what values of x we keep and which ones are not valuable, or which ones are extraneous solutions, the ones we have to throw away because they would make m less than 0. Okay? So, if you notice, m is this whole piece right here. That's your m. And so that part has to be greater than 0. So what we can do then is we can go over here and we can solve. We can say 4x, and was it minus 7, has to be greater than 0. And we can solve it. 4x is greater than 7. Whoops, I shouldn't have put that equal there. Greater than 7. And divide by 4. So when we get our answer for x, it has to be greater than 7/4. Okay? Which is 1 3/4. It has to be greater than that. If it's not greater than that, then we know we can't use that answer. And the same thing applies over here. I didn't erase it. This is our m. M in this case is just x. So x has to be greater than 0. So if we happen to get a negative number for our answer, we know that's going to be no solution. We can't use it. All right, now there's two log equations that we know right now. One is where the log is on one side and there's only one log. And that's what we have here. There's only one logarithm. Okay, there's not a log on this right side. So our way to solve that is we're going to put it in exponential. Put it in exponential form. To solve it. And the way you put it in exponential form, remember, your base is the 3 to the exponent 2, and that equals 4x minus 7. Okay, 3 to the squared is equal to 4x minus 7, so 9 is 4x minus 7. Add 7 across, you have 16 equals 4x, and divide by 4, so x equals 4. Okay, and that should be your answer. You can check it, but you don't really have to check it, because you know that that's greater than 7/4, but it certainly doesn't hurt. We can go ahead and check, do our check here. If I could spell check, it would help. Okay, that means we're going to put 4 back in our original equation. We have the log base 3 of 4x minus 7, log base 3 of 4 times 4 minus 7 equals 2. Exponential, that means you have 3 squared is equal to 16 minus 7, or 9 equals 9. And so that does check out as being a good answer. So 4 equals x is a correct answer. Looking at number 2, this is another type of problem. It's a different way to solve it. You've got logs on both, the word log on both sides of the equal sign. Well, then you're going to use that rule that if you have log, where is it? Let me see if I can get it written out here. Log base b of m equals log base b of n, then m equals n. And that's a rule that you're going to use. So we see that they're log base 5, but we first need to simplify on the left. That's log base 5, and that 2 comes back up of x squared equals log base 5 of 9. So there's your m here, and here's your n, both log base 5, so that means then that x squared must equal 9. Well, when you square root both sides, you find that x squared equals, x equals then plus or minus 3, okay? But we know that x has to be greater than 0, so our negative 3 should be a bad choice because we can't take the log of a negative number. And so we're going to be our answer is only going to be x equals positive 3. Only the positive one is going to work in this case, because otherwise we'd have log base 5 of negative 3, and we can't take the log of a negative number. All right, let's look at example 4. What happened to my example 4? Thought it was on the next page. There it is, 3 and 4. Okay. Example 3. Well, we have two logarithms here, but they're on the same side of the equal sign. So we want to combine those into one logarithm. And we can do that because remember, if there's a plus between them, that means that's a product. So what we're going to do is combine those into one, and that's going to be log base 4 of x plus 3 times 2 minus x equals 1. Now we have a log on one side, so we're going to put it in exponential. That was like example 1. The word log is only on one side of the equal sign. So you're going to say 4 to the first is equal to x plus 3 times 2 minus x. And we also need to know that all of this has to be greater than 0. But let's multiply it out first. So when we multiply, we have 4 equals, then this is going to be 2x minus x squared, okay, plus 6 minus 3x. And when we combine all that together, you have negative x squared minus x plus 6. Now I need to factor this, and since that's pretty difficult, really, if I was going to do what I did before, I'd have to multiply through all this, set it equal to 0, and see what my value, if there was an extraneous value. And you can certainly do that, but you're going to have to well, let me go back. There's not a lot of room. I'm going to do this up here. Okay. If I had x plus 3 times 2 minus x is greater than 0, that means that neither one of these could be equal to 0, right? And the two values that would make it equal 0 are negative 3 and positive 2. Okay? Those are the ones that would make it equal 0. Then we'd need to figure out what would make it less than or greater than 0. So to me it gets a little complicated. I would just as soon solve it and then test my answer. But then that's just me. Okay. So I don't want a negative here. I want to move it all over. So I'm going to say x squared plus x minus 6. That's moving everything to the left. And then I'm going to still have my plus 4, and that equals 0. So x squared plus x minus 2 equals 0. Then I need to try to factor. Okay, so that leaves me with x plus 2 and minus 1 if you're going to factor it. So my solutions are negative 2 and 1. And I need to test, back in my original equation, to see which of these is going to work. And here's my original equation, x plus 3, 2 minus x. Okay? So I need to check x plus 3 and 2 minus x with these two values to see if any one of those is going to be negative. Well, negative 2 plus 3 is positive, and 2 minus 1 is positive. Oh, 2 minus negative 2, excuse me. Putting the negative 2 in there, that's going to also be positive. So that value works. Then I have 1 plus 3 is positive, and 2 minus 1 is also positive. Okay, so this value works. So both of those are good answers. So in this case, x is equal to negative 2 and 1. And those should both be good answers. Now, let's look at this one on the left. Again, now this is easy because of this x here. X can't be a negative number because that would mean that I would be taking the log of a negative number. So any x that comes out to be negative, we can automatically discard because it would make us be trying to take the log of a negative number. But this principle is the same as in example 3. I have to combine these into one log. So that makes log base 3 of x times x minus 6 equals 3. Now put it in exponential form. So that's going to be your base times your exponent. This is your base, and this is your exponent here, the 3. So 3 cubed is equal to, and I'm going to distribute these, x squared minus 6x. Okay, so 9 is equal to x squared minus 6x. Now, since that's a quadratic, I'm going to need to bring the 9 over and see if I can factor it. Set everything equal to 0. So 0 equals x squared minus 6x minus 9. Factor x, and 0 equals, multiply to be 9, add to be negative 6. That's 3 times 3. But 1 has to be positive, or 9 times 1, so we're going to have to use quadratic formula, it looks like, on that one, which is not fun. So let's see what we can do with that. Okay. So we have, 3 cubed is 27. So if I could, I made a mistake. Not unusual. What just happened? Okay. Let's try this. Okay, there we go. So that should be 27, and that means this here should be 27. Now let's see if we can factor it. That's going to make a big difference, I hope. All right, so 9 times 3 is 27. That's going to work. So we have x, we have a plus and a minus, because this is, second one here is negative. You know, you have a plus and a minus. So we have 9 times 3, and negative 9 plus 3 is negative 6, and negative 9 times 3 is negative 27. So our answers are negative 3 and positive 9. I know right away it can't be that negative. And the reason it can't be the negative is because right here, that would mean in this negative x right there that I'd be trying to take the log of a negative number. Now, does the 9 work? Log, I can take log of 9, and I can take the log of 9 minus 6, which would be 3. So 9 does work. So 9 is the right answer for this problem.